Hello, you're welcome back, and this is the second video, and hopefully in this video we'll round up what we intend to cover. All right, so don't forget, from the mail, of course, if you're watching this video, you should know that there's a mail in the video, there's a link in the video where you can download all of this. All right, the materials I'm using, the data, the description, and the SPSS file. All right, and in the last video all right, so before we go forward again, I'm going to remind you of this, and it's what more than the money. If you're interested, if you can afford it, fine. If you can't, you can go through the YouTube videos, and you gain one or two things. All right, so in the last video we talked about one sample, talked about the preliminary analysis that you should do when assuming you are writing a paper for publication or for dissertation to be submitted, how to get the best out of your data. Then we talked about one sample t-tests, dependent pair t-tests, independent t-tests. Now, one-way ANOVA. We said to use one-way ANOVA, you must have a scenario where you want to test for the mean difference between at least three groups, three independent groups. All right, three independent groups. Now, okay, so for one-way ANOVA, the objective here is to evaluate whether cholesterol levels differ significantly across three BMIs, the BMI categories: underweight, normal weight, and overweight. In fact, it's not three, it is four. Among four. Okay, this is PDF. Among four categories. All right. So let's do that. The first thing we do is to categorize the BMI. The BMI is given to us in the exact measurements. So how do we categorize it? We go to transform and visual binning. Where is BMI? Bring BMI here and continue. So bin variables, BMI, let's just call it BMI cat for BMI categories. So here we leave it as BMI. Now make cut points. First cut point should be at 18.5. Number of cut points, because we want four categories, so we'll be having three cut points. All right, so like if you want to divide a loaf of bread, if you want to divide it to four, how many times are you going to cut? You cut 3 times. All right, so width, it automatically calculates the width. Apply. So let's see if this calculation is correct. So the first one is 18.5. Second one is between 18.5 to 24.9. So here we change this to 24.9. And here we have 29.9, 29.9. Then we have I. So for this guy, the label is going to be underweight. Underweight, normal weight. We have overweight, and we have obese. All right, so once you do this, you are good to go. And okay, so binning specifications will create one variable. So now we only have the code here, but to see what we have done, you have to come here to see. You can see we have obese, normal. So it creates this categorical variable according to the BMI values. All right, so now we have our independent samples. Yep, independent samples, and we have evaluate whether cholesterol levels differ significantly. So let's see, cholesterol levels differ. So let's do cholesterol levels before. Cholesterol level before. So let's see, analyze, compare means one-way ANOVA. So cholesterol levels, let's pick the two two cholesterol levels, pre and post, and then the BMI. Now, when we do this, and the cholesterol, if the cholesterol levels are significantly different, how do we know which ones are particularly different? You know, what we are saying is that across the four levels, are there differences? So ANOVA will just tell us yes, there are no differences. Now, to specifically know where the differences, where the interactions are taking place, we carry out something called the post hoc test. So the post hoc test would break it down. Just choose 2 and that's okay. And okay. Now, looking at this, the one we ANOVA, we have cholesterol pre. Is there a significant difference between, there are no significant difference between the cholesterol levels before the treatments, and there are no significant differences after, this is post, after administering the treatments. So since this is not significant, they are not significant, we don't need the post hoc tests. All right, the post hoc tests are not needed, because even here there would be no significant differences among them. All right, so if we want significance, we should get among the glucose level. So here we can say that the treatment A and B, okay, this is not treatment. All right, this is not treatment now, it is across the BMI. Okay, so across the BMI, so let's see here again, here no difference. So you can't say there's any difference between the BMIs of these people. I mean the glucose levels across the BMIs. There's no difference between the cholesterol levels across the BMIs. No significant difference. Not that there's no difference at all, but differences that exist, they are not significant. So here we say we reject the alternate hypothesis. All right, and we do not reject the null hypothesis. Now, two-way, you know, for one-way ANOVA, we had just one categorical variable, but for two-way, we have two independent variables acting on something, predicting something. We want to check difference between the here, let's say, examine the effect of gender and treatments, drug A versus B, on post-treatment glucose level, post-treatment glucose level. So we are looking at two categorical variables irrespective of their levels, as long as we have two categorical variables. So this is examine effects of gender and treatments. All right, so let's see, analyze. We have general linear model, univariate. Dependent variable is glucose level, post glucose level. That's dependent variable. Then the fixed factor, age, and no, is it age? Gender, sorry. Gender and treatments. All right, so let's see what we can do here. We don't need this. Contrasts. Okay, plots. Continue, post hoc. All right, let's see gender and treatments together. Again, 2 okay. Display means for let's bring all of them here. Compare main effects. I'm just picking, you really have to pick all of this. Unstandardized. All right, so we go ahead now. Let's look at okay, so for gender has significant effects on the post glucose level, post treatment glucose, and treatment does not have, and the joint effect of gender and treatment also does not have. So gender is a significant factor that predicts or that is able to affect that is able to affect the post-glucose level. All right. So now the next thing is Pearson correlation. Test the correlation between BMI and glucose levels. All right. So we'll actually do more than one. Okay, let's do one. Test the correlation between BMI and glucose level. You go to analyze, compare means. Correlates, bivariates, and BMI and glucose